Hi, my name is RASYIQAH. Now I will start with the introductions of gravimetric analysis. Gravimetric analysis is the precise method used in analytical chemistry to determine the quantity of an analyte by converting it into an observable product that can be isolated and weighed. So this technique is highly valued for its accuracy and reliability, which are essentials for quantitative analysis. Its importance extends to environmental monitoring, where gravimetric analysis is utilized to detect and quantify pollutants in air and water by providing accurate measurements of contaminants. This method plays a crucial role in assessing and maintaining environmental quality.
Hello everyone, my name is AZZAH, and today I will discuss the principles of gravimetric analysis, which is an analytical method that quantifies a substance by its mass. In gravimetric analysis, full precipitation can occur where impurities are trapped in the precipitate's crystal structure, affecting purity and mass. There's also post-precipitation, which is the formation of a precipitate on an existing one, possibly due to initial undersaturation reaching saturation. The concept of relative supersaturation is important. It describes the level of saturation relative to the amount of precipitate formed. High supersaturation can lead to rapid precipitation and encapsulation of impurities within the crystals. The solubility product, or KSP, is an equilibrium constant specific to each compound that predicts whether a precipitate will form under certain conditions. The principle behind gravimetric analysis is straightforward. We transform the analyte into a solid precipitate, which we then filter, wash, dry, and weigh. The mass of this precipitate allows us to calculate the quantity of the original analyte present in our sample. For example, analyzing water for sulfate content by introducing barium chloride to precipitate barium sulfate. By measuring the mass of this barium sulfate, we can deduce the amount of sulfate in the water sample. In essence, gravimetric analysis relies on precise and accurate mass measurement to determine the quantity of a substance, making it a classic yet widely utilized technique.
Assalamualaikum warahmatullahi wabarakatuh. I am FAZLIN. The channel now we present about steps in gravimetric analysis. So there are 7 steps in gravimetric analysis. In gravimetric analysis, the initial step is solution preparation. Preliminary separation might be necessary to eliminate interfering substance. Adjusting solution conditions is important to maintain low precipitate solubility and enable easy filtration. Factors to consider include solution volume, test substance concentration range, presence of other constituents, temperature, and pH. pH is especially critical as it affects precipitate solubility and potential interference. Next, in the precipitation process, a specific agent is added to sample solution to create a precipitate by reacting with the analyte. The selection of the precipitating agent is of utmost importance as it needs to react selectively with the desired analyte, resulting in a precipitate that has minimal impurities and low solubility. Third is digestion. During digestion, larger crystals grow at the expense of smaller ones when precipitate is left in contact with the mother liquor at a specific time. This helps to improve the purity and particle size of the precipitate, making it easier to filter and weight. Next, washing and filtration. Precipitation involves separating the precipitate through filtration and washing to remove impurities. The choice of wash liquid is important to prevent peptization. Testing the filtrate confirms complete washing. This process yields a purified precipitate for further analysis. Furthermore, drying or ignition. If the collected precipitate is suitable for weighing, it needs to be heated to eliminate water and absorb electrolytes from the washed liquid. Drying is typically accomplished by heating at 110 to 120 degrees Celsius for 1 to 2 hours. However, if further transformation of the precipitate is required for accurate weighing, ignition at higher temperatures is often necessary. Next step is weighing. The dried precipitate is weighed using a calibrated analytical balance by applying proper weighing techniques to ensure accurate measurements. The obtained weight is used for subsequent calculation related to analytes, amounts in the original sample. Lastly, calculation uses stoichiometric mole relationship. The gravimetric factor GF is determined. The GF represents the weight of the analyte per unit weight of the precipitate. It is obtained by multiplying the ratio of the formula weight of the analyte to that of the precipitate with the mole of analyte per mole of precipitate derived from each mole of analyte. In gravimetric analysis, our primary objective is to determine the percent composition by weight of the analyte, which refers to the substance we are specifically seeking to analyze. So, beside me is the formula that used.
Hi, my name is HANANIA and my presentation focuses on the application of gravimetric analysis in environmental monitoring. In environmental monitoring, gravimetric analysis is often used to measure the concentration of various pollutants such as heavy metals, sulfates, nitrates, and particulate matter. For example, in water quality monitoring, gravimetric analysis can be used to measure the concentration of sulfate ions by precipitating them as barium sulfate. The sample is treated with a solution of barium chloride, which reacts with sulfate ions to form a white precipitate of barium sulfate. By filtering, washing, drying, and weighing the precipitate, the amount of sulfate ions in the water sample can be calculated. Next, in air quality monitoring, gravimetric analysis is commonly used to measure the concentration of particulate matter PM in the air. Particulate matter refers to tiny particles suspended in the air that can have harmful effects on human health and the environment. Gravimetric analysis allows for the accurate measurement of the mass of these particles in the air. Last but not least, gravimetric analysis is also utilized in soil contamination monitoring to quantify the concentration of pollutants or contaminants present in soil samples. By measuring the mass of a precipitate formed during a specific chemical reaction, gravimetric analysis provides a precise method for determining the amount of contaminants in the soil.
Hi and Assalamualaikum. I am DINI MAISARAH and I am going to continue the presentation by explaining about the real-world example of gravimetric analysis. So let's get into it. The first example is that we can count or determine the gold content in jewelry, where this is the oldest way to determine the content of the gold, and this is the most reliable method that we can use. The second example is we can count the amount of fat in milk because we need to use properly calibrated method. And one of the method is the Mojoneer method, and it is one of the gravimetric method that use organic solvent to extract the fat out of the milk, and the fat will be dried and weighed. The third example is that we can count the lead level in water for human consumption, where it used the gravimetric analysis because if not, it can cause poisoning and death to human. Then the other example is it is also used to determine the sulfate content in fertilizer, and it used to calibrate instrument because it can provide accurate and correct data, and it also helps to limit the number of instrumental error. As an example is we can measure the volume of plasma in blood.
Conclusions. Gravimetric analysis stands out as a fundamental technique in analytical chemistry due to its exceptional accuracy and precision. So this method's ability to convert analytes into measurable products makes it indispensable for quantitative analysis. In environmental monitoring, gravimetric analysis plays a vital role in detecting and quantifying pollutants, thereby aiding in the assessment of air and water quality. The applications of this technique not only ensures reliable data for environmental protection, but also highlights its significance in ecological balance and public health. Through continued use and development, gravimetric analysis remains a vital tool in safeguarding our